Okay, so I just have graphed like a function here, and on this function, what I want us to do is think about what the tangent lines would look like at all of these points that I have put here. So if I have a tangent,
Chandler never got that.
does anybody have extras anywhere? Oh, Selena. Sorry. Alright, so if we draw in a tangent line here at A. Not the function is not positive, but the derivative is positive. Right, function is increasing at that point. Then at this point here, at B, we've got a horizontal tangent. So at this point, we have a horizontal tangent. Is our function increasing or decreasing? Neither one. All right. Over here, we have a negative slope. Our function is decreasing. All right. This is not the best graph necessarily. But it can. So tangent lines. Let me think about this for a second. Tangent lines can they cross the graph again later?
Absolutely. I mean, they go on forever, so I think there has to be a point where.
I need to think about that one more. I'm not sure if it's just because my graph is drawn right poorly or yes. Then the graph is what? It would be, yeah. Pretty well. I don't know if that's true either. Yeah, but
As long as your line has every single corresponding point of slope,
it wouldn't be true for something like this. Let's see. Like this. Because you would have tangent lines everywhere here. So it'd fill up pretty much everything above. But you'd have blank spot down here. One right here, I think it would cover up everything. Yeah. And then over here we had one more spot where we've got the tangent line. Are we increasing or decreasing here at D? Increasing positive tangent. Okay. So if the derivative of a function is positive, the function is increasing at that point. If the derivative of a function is negative, the function is decreasing. That is not related to what we're doing right now.
Tell me its actual projection.
Alright. So, we are supposed to find the intervals for which f of x equals 3x squared plus 4x is increasing and decreasing. So, what we need to know, because we'll be doing this without a calculator, like we could graph it on Desmos and find it really quickly if they let us, but this will be on non-calculator. So, if the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. So we're going to take the derivative Okay? So we get 6x plus 4. What we want to do with our derivative is we want to find the critical points of that derivative, because critical points are where our derivative equals 0 or our derivative is undefined. These are going to be the places where we switch from positive to negative if we're going to switch from positive to negative, right? Because if you have something that has a derivative that is continuous, if you take the derivative, if it is negative here and positive up here, what's it got to cross to get there? It's got to cross that x-axis. It's got to be 0 at some point. So those are your critical points. That's what you're looking for here. So for this one, we just set it equal to 0. We would subtract our 4. 6x equals negative 4. Divide by 6. X equals negative 2/3. So this is our critical point. What that tells us is if the derivative is going to switch from positive to negative, it's going to switch at that point, not anywhere else. It's not going to switch from positive to negative at 2 or negative 7 or at 1 or 0. It's going to be right here. So it's the only time it could possibly change, but sometimes it does not actually change from negative to positive. Sometimes it might be negative in both places. It might be positive to negative or negative to positive. Right. So you got sort of two options of what can happen right here. So I know that my derivative equals 0 here. So at negative 2/3, that derivative either goes like this from negative to positive. It could go like this from positive to negative. Or it could do something like this. It could go like this. Or it could go like this. It could be just barely touches at that point. So it just depends. So we have to check to see what's happened. So we're going to make what is called a sign line. And so we're going to make a number line, and we're going to put our critical points on here. Now this is going to be a super simple one because we only have one critical point. A lot of them are going to have more than one critical point. So, and we are going to label this f prime of x. We're worried about the derivative here, which is going to tell us something about the original function. So what we can do is we can pick any number below negative 2/3. We did this some when we were doing inequalities, when we were doing rational inequalities in pre-calc. We did sort of the same sort of chart, although it was a different context. We weren't doing increasing, decreasing stuff. So if we pick any number here, every number in that section is going to have the same sign. They're all going to be negative or they're all going to be positive. So what's an easy number to pick that's less than negative 2/3? Not 0. Negative 1 would be good. So negative 1, 0 is a good one on the other side. That would give me negative 2. So this is negative. That tells me everything in the section is negative. And so if I pick a number like 0, 6 times 0 plus 4 would just be 4, which is positive. So that tells me everything in this section would be positive. So we have just found that the derivative is negative from negative infinity to negative 2/3, and that the derivative is positive from negative 2/3 to infinity. So let's think about what does that tell us about our function, our f of x.
Negative. Oh, it's a decreasing less than that value and increasing
is increasing here. Okay, so if our derivative is negative, our original function is decreasing. If our derivative is positive, our original function is increasing. Now, here's the thing that AP is very particular about. This chart right here is not enough for your answer. So, on the, yeah, I like the chart. And I always draw the chart because it helps me organize my thoughts. But, in order to get credit for a problem like this, if it's showing up on free response, and it will sometimes, you're about guaranteed to have something where you got to do this on free response. So, you must say f of x is decreasing for negative infinity to negative 2/3. Make sure you don't say at there. Some of you were saying at. When you're talking about an interval, it's when you're talking about an interval, it's over a period of time. So you could say for this interval or over this interval. But at is not really the best thing to say because that makes it sound like it's at a single point. But f of x is decreasing for negative infinity to negative 2/3 because f prime of x is less than 0 for negative infinity to negative 2/3. There's other ways you could say that. You could say because the derivative of f is negative. You could say because another way's not coming to me, but you have to tell why. Yes. And you have to justify it with the derivative. You must justify it with the derivative. You cannot justify it by saying something like f of x is decreasing because the line is going down or something. But it is not justifying it. That's just a definition of something being decreasing. Right?
So anytime you get the critical point, it'll just tell you what it is at. But like that, will it always be negative or like positive, or can it just be positive?
Sometimes anything could happen here. It could be negative. Both of them could be negative. You could have both positive. You could have positive then negative. So that's why you need to test those points. So depending on the function, right? That critical point is going to be the spot where it switches. Okay. And then we would also here need to say f of x is increasing for negative 2/3 to infinity because f prime of x is greater than 0 for that interval. Yes. Okay. All right. Next one. All right. We're getting slightly more difficult here. We need to take our derivative. Okay, Alfredo, tell me how to take that derivative. Okay, tell me what I'll get.
2/3 times x squared minus 9 times 2x.
Almost to the negative 1/3. Which it is going to be to your advantage here to rewrite that so that you would have, let's see, this is over 1. We're going to send this one back down to the denominator. So we'll have 4x over 3 cube root of x squared minus 9. And even if it was not, you still could not just square root both of them because they got plus or minus sign in between them. So if it was square root of x squared minus 3, you could not say it's x minus 3. Uh-huh. The top part is going to be 4x equals 0, which is going to give us x equals 0. But critical points also happen when the denominator is 0. So we want to set the denominator equal to 0, but really it's not that bad. Because divide by 3. Yep. And so you're going to cube both sides. Since this is 0 over here, it really just ends up being x squared minus 9 equals 0. So x squared equals 3. So I'm sorry, I'm a step ahead of myself there. Should get 9 on that step, and then we'll get 3. Yep, plus or minus 3. Yeah. So our critical points when we make our chart is we're going to have negative 3, 0, and 3. It does, but a graph can switch from positive to negative if you have an undefined slope. A lot of times that's going to be where you have maybe a vertical asymptote, and so it's pretty common to have a jump from a negative to a positive at a vertical asymptote. Yeah. So, all right, so now this one is not super easy to plug into. So I like to break it down into pieces that are easier to plug into. So I like to break it down into like factored out portions. So the top is 4x and the bottom is 3 cube root of x squared minus 9. I'll show you here in a second. You don't have to do it this way. You could just plug numbers in like we did on the last problem. On the last problem, there was nothing to put in the chart because you just had a really simple expression for your derivative. So you can put each factor in this chart. So 4x, if I plug a number into 4x, it's much easier than plugging it into the whole thing, right? If I plug in a negative, I'm going to get a negative. If I plug in a positive, I'm going to get a positive for 4x. We did. It was with inequalities, but we made these charts because we were worried about. We're not going to plug in the numbers 0. We're plugging in numbers between negative 3 and 0, like right there. So, like if we plugged in negative 2, 4 times negative 2 gives us negative 8, which would be negative in that section. So you're not plugging in the critical points because those should give you 0 or undefined, right? Because that's how we got those. We're picking numbers between. So if I pick a number like negative 4, negative 4 squared would give me 16. 16 minus 9 would be positive, so I would be positive. What about if I plugged in like negative 1? Actually, what if I plug in negative 1 squared? I get 1 minus 9 under the square root. I got a negative under the square root. This is actually undefined. It's going to happen with a positive 1 as well because you got a negative under the square root. Because you have a negative under the square root if you plug a number in. Oh, wait, I take this back. I'm lying to you. That would be true if it was square root. It's not a square root. This is a cube root, and it is okay to have a negative under a cube root. Sorry, guys. So, a negative under a cube root is negative. So you're going to get a negative here. Sorry about that. And then we'll also get a negative here, because if that was a positive 1, we'd still get the same thing. And if we plug in a positive 4, we would get a positive. So, negative divided by a positive is going to give us a negative. Negative divided by negative will give us a positive. Positive divided by negative gives us a negative. Positive, positive is a positive. So this line right here, that last one I just filled in, that's the one we care about. That's our answer. This stuff up here is just helping us get the answer. You might not like doing that. You might would rather just plug into the derivative. You can do that also if you prefer. It is, we're just doing it like piece by piece instead of doing it all at one time. Yeah. You can. We're going to see when we get derivatives that are a little bit bigger where this is really beneficial. But it's not required. Like, you don't have to do it that way. So, and if you have, like, if we have more things here, if you have odd number of negatives, it's going to be negative. If you have an even, it's going to be positive. We did do this in pre-calc.
I remember making these charts. We didn't have to write out. Oh my God, I forgot to write out.
Yeah, we weren't taking derivatives. We weren't doing all that, but so you do have to write this out. So you would have to say for let's see. Actually, let's see. F of x is decreasing on negative infinity to negative 3 and 0 to 3 because the derivative f prime of x is negative or is less than 0. F of x is increasing. You write this down on negative 3 to 0 and 3 to infinity because f prime of x is greater than 0. End is fine, but we won't have tomorrow.
You can work on it today after school.
I'm probably not gonna stay past 4 o'clock tomorrow. So have everything done that you can get done, and just bring me questions. Okay, so if you already have them, you may turn them in. Yeah, especially since you will not be here tomorrow. All right, so we don't have time to do the rest of this. We need to. All right. All right. The assignment is at the end of this, and what did I say it was?
I
can't remember. I don't have it out. All right. All right. 1 through 8. 1 through 8, I do want you to do. You're just doing those from the graph, though. So it's you don't have to take derivatives. And then which ones did I say? 9 through what? 20. Let's make that odd for the 9 through 20. Let's make that odd on 9 through 20. All right, my neighbor's called me twice.
Do you know what time you're performing? Oh, I wouldn't be able to make that. I got hey, did this might just say 1 through 8?
Hey, everybody, real quick. I want to say something. Hello. Hey, everybody, listen up real quick. So, everyone, I know everyone in here is really active. There's a blood drive coming up, and if you want a red cord, talk to me. You want a red cord? So, you can get out of pretty much. It looks good on your graduation. You can talk. It's a good way to get involved. It's Friday, December 10th. We'll have forms. Yes, question. Okay, so you can help come. You can recruit people. 2 people is what we're requiring our cadets to do.
I'll do it.
So get 2 people, or get 2 people, or give blood, or you can come help out and get. So there's 3 options to get that red cord. So if you have AIDS, you can't do it.
Wait, so you tell me I can't donate AIDS?
But that's just a. Dude, you got jacket. That's so sick. That is so sick.
Wait, Laura, why can't you get blood?
Are you calling us back?
Good news, my house is not on fire. I just need to pick up a package from home. I took basketball, so I won't be here.
Do you have a line for this class? Or can you just send me an email on what you want us to do over the break? If you do change it from...
Yeah, if I change it, I'll send you. Yes. Yes, odds on those. So really 9 to 19. Yes. Yes. Come on in, Silas, right? Daniel, you gonna put both? You gonna be able to put them both? Yeah. Okay. Which one are you asking me about? Okay. Oh, this one. This one is like the reason you should say the word sick.
Yeah, I went.
Because watch this.
Because I got like cosine e of y times e to the y.
Thomas, you might want to. Is sine y equals e to the x or is it backwards?
Sine x equals e to the y.
Okay.
Which question is this?
What number is it?
14.
14 on multiple choice.
Oh yeah, this is it.
Okay.
You
This
gotta
is
take out a
crazy.
picture when I'm.
Because it's so easy at first and then it's crazy. So, take the derivative, you get cosine x equals, derivative here is e to the y dy dx.
Wait, you want to bring the y?
Derivative of y is like any e, it's just its own derivative. And then derivative of y is dy dx. So that's like two more steps. So then you just divide both by each one.
Yeah, I got there.
So, this is the answer, but it's not any of your answer choices. So, watch what they do. E to the y equals sine x.
Oh.
So, this equals cosine x over sine.
That's the wackest thing.
Equals cotangent
Why would you
x.
do that?
To make your life miserable and difficult.
That's just annoying.
Because they're evil geniuses that are writing the AP exam.
Wait! Are we doing beta?
Football.
Football, yeah.
Oh, they can
Oh my god, will we? Do you understand?
Where are all the girls? Did they quit on me?
Hopefully.
Why does it equal y? Or what is e? Is that the equation?
Yeah.
Alright.
The derivative?
And then it cancels that. So up by and then you plug that in over here because it's e to the y. Yeah, but what is? Oh, you divided.
Yeah, so like,
You have to get rid
you
of
did
the-
this right here. Just took the derivative here,
Oh, okay.
derivative here.
Yeah.
Right. And then you divide by the e to the y because e to the y dx. That's it. So you get this. So this like is where we would stop if we were doing the problem normally. It'd be a pretty easy problem. But it's none of your answer choices. So because this has to be true because it's the original, e to the y equals sine x. So you can replace e to the y with sine x. And you make this cotangent.
Yeah, that's.
Which is really aggravating because it's an easy problem except for the answer choices make it hard on that.
I was stuck on that problem.
Okay. All right.
What would you like, Parker?
That's interesting. Okay.
Blood drive for seniors and getting older.
Okay.
We actually have 2 blood drives, so I brought it up to the class because I know a lot of them want stuff on their graduation.
Yeah.
And it's always like, so I'll bring it up to them. Since it's always kind of, it has to relate to giving blood. So you can give blood, get 2 people to, like, you can have your parents come or anyone else, and that also will work.
Oh, so you can get cords even if you don't
Just
get
as
blood.
long as
Okay.
you recruit, like you have to have your name attached to whoever. So, because blood is blood.
Yeah.
Like if you're not eligible, what are you gonna do?
Right.
Like you want to help.
Wait, so you get to say.
You have to recruit people.
So you can recruit people to give blood for you.
But they have to they have to acknowledge that they can't they can't just go. You have to be like, this person was my person that I got, and they have to be like, yeah. Just like I wasn't able to give blood for my freshman sophomore year, and then when I was eligible, because I was old enough, but when I was my junior and I was old enough, 16-year-olds can get parental consent, and 17-year-olds you don't need consent, but you need to you still need to make sure you pass all the tests and you're healthy enough, and meet all the weight requirements and all that. And doing that, you need to still make sure it's okay. Because like my parents, they do not want me to do it, even though I want to. I was like, because I was problems with my family, and just, like, they're create that something to, and like that's why I don't drink energy drinks either. And I'm willing to know. I think.
Yeah. Ethan, you do not need energy drinks. Okay.
On the walls, like.
You definitely do not need it. All right. Let's see. Let me find my questions here. I know. I don't know why. We had 4 girls last time, but nobody is here.
All right, so I say seniors versus freshmen. Oh, we got this is one.
Yeah, Hunter is also willing to participate in this bowl.
Oh, Brayden's playing today too.
Oh, is Braden coming to play? All right, so
Brayden's playing too.
oh, Braden's coming. We'll let you each have an elementary school student on your team. All right, so
Who's doing chip? Who's team
oh,
should I
gosh.
be on?